Today we're going to talk about how to solve pretty much any problem in dynamics. If you follow this procedure, you will be able to succeed in most of the problems. So here's the procedure itself. First, what you have to do is to make a drawing. In fact, I actually encourage everyone to make a drawing for any problem in physics. Next thing you're going to do is to draw all the forces and acceleration on that drawing. Third, you're going to write Newton's second law in vector form. Fourth, you're going to draw a coordinate system. 5, you're going to write the components of all the forces and acceleration on the axis of coordinate system. And the last part, you're going to write Newton's second law for the component of those forces and accelerations. Now let's apply the 6 rules to a dynamics problem. Let's say we have a slope with an angle theta, and we have an object on the slope. The object slides down without friction. And let's say initially the object is at rest at specific height above the ground. We know that height. And we could be asking a question like how long it will take for the object to go down in the slope, or what kind of velocity the object is going to have at the end, or things like this. But no matter what kind of questions you're being asked, you're going to solve this problem about in the same way. So first you're going to draw the picture, and we already have this picture. Next, you're going to draw all the forces and accelerations. So there are 2 forces acting on this object. There's a gravity, the vertical force, gravity down. We also have a normal force at 90 degrees to the slope. And since the object is sliding down the slope, it's not jumping off the slope, it's not going in digging into the slope. Acceleration should be along the slope. The next thing we want to do is to write Newton's second law in vector form. Newton's second law says that net force, or sum of all forces acting on this object, should be equal to mass of this object times acceleration. The next thing we're going to do is to introduce coordinate system. We can put any coordinate system we want. And no matter what coordinate system we put, we should be able to solve this problem. The difference is for some coordinate system, math is going to be simple. For some coordinate system, the math may not be that simple. In this particular case, we introduce coordinate system where one of the axes, x, is along the slope and the other, y, is at 90 degrees to the slope. Next, we're going to write components of the forces and accelerations on this coordinate axis. Notice the normal force is strictly along the y direction. So the components of normal force will be 0 in x direction and some number n in the y direction. We don't know what this n is, but by the end of this problem, we will know what it is. Now let's write the components of the gravity force, mg. Notice mg is not along x or y direction. So mg is going to have component along x direction and along the y direction. To understand what these components are, we need to notice that the angle between the vertical axis y and vector mg is theta, same theta as here. It's an angle of the slope. This follows from the fact that both of these angles, one black theta and red theta, are at 90 degrees to each other. Now, if you are not familiar with this fact, I actually highly suggest that you try to derive it on your own. What we're going to do now here is we're going to use this fact. The horizontal component of mg, component on x-axis, will be this purple vector, and the vertical component will be this yellow vector. Horizontal component will be mg times sine theta, vertical component will be minus mg cosine theta. Notice there's a minus sign here, and that's because the vertical component is going in direction opposite of the vertical coordinate. Acceleration A is along the x direction, so it's going to have some component A in x direction and 0 in y direction. So now what we're going to do is to write Newton's second law for the components. So this law should work for x component and for y component separately. For x component, this is the equation we're going to get. And for y components, this is the equation we're going to get. The first equation gives us acceleration A. The second equation gives us the value of normal force m. Notice that g is constant and theta is constant. Therefore, A is constant. So essentially, when we're looking at the motion of this object moving in one dimension with constant acceleration. And you can use a well-known kinematics formulas to describe the time it takes for the object to go along the slope, and also what kind of velocity this object is going to get at the end. And I leave it for you to solve. The other problem I suggest you try is to change the coordinate system. Remember, I told you that we should be able to get the same answer no matter what coordinate system we have. So what I suggest, you choose a coordinate system where x is actually horizontal and y is vertical, and try to get this answer. Good luck.